Good morning, everyone, and welcome back to the 2016 Open Simulator Community Conference. I want to remind you all, in-world and our web audience, you can view the full conference schedule at conference.opensimulator.org and tweet your questions or comments to @OpenSimCC with the hashtag OSCC16. We had a great day of presentations yesterday, and if you missed them, never fear. We'll be posting them on our site and all of today's presentations as well in the near future. So definitely look for that. This hour, we are happy to introduce the session called Virtual Robotics, Creating, Collaborating, and Constructionist Learning in a Virtual World. Our speakers are Carina Girvan and John Lester. Dr. Girvan is an academic at Cardiff University and co-editor of the British Journal of Educational Technology. Interested in new technology, she has been actively researching the use of virtual worlds and robotics. In this project, she brings these interests together as part of a European Commission funded project on educational robotics for STEM. And John, Pathfinder, as many know him in the virtual world, Lester, is currently a product manager at OpenText and has been a pioneer of developing educational communities for Linden Labs, Open Simulator, and Unity platforms. John also sits on the board of Virtual Ability as a champion for accessibility. Welcome to you both, and I will pass the mic to Dr. Girvan.
Okay, thank you very much. So my name's Carina Girvan. Thank you for the introduction. And yes, today I'm going to be talking about virtual robotics, creating, collaborating, and constructionist learning in a virtual world. In World and its second life, I'm known as Sleepy Little Thing. And I'm really lucky to have met John, who has worked as a consultant with me on this project. And hopefully what we're going to talk to you about today, you'll find really interesting. It'll be a little bit different maybe for some of you, and it's a lot of fun for us. So I hope you'll enjoy it. Just to give you an overview to the talk, I'm going to talk to you a little bit about the background to the virtual robotics project that I'm involved in, just to set the scene. And then myself and John will talk a little bit about why we're using OpenSim for this project and the design of the environment. I'm then going to talk to you a little bit more about Slurtles, and we'll have a demonstration of them in action. And then I'll talk just very briefly about what the next steps are for the project, and then we'll open up to Q&A. So, just to tell you a little bit about the robotics project that's funded by the European Commission. It's called ER for STEM, or Educational Robotics for STEM, and it's a collaboration between 7 institutions in Europe. It's led by the Technical University of Vienna, and then we have a pedagogic partner at the University of Athens. And myself at Cardiff University, I'm involved in the pedagogy, doing the virtual world angle, and I'm also evaluating the whole project. And then we have the Practical Robotics Institute of Austria, Certicon Across Limits, and the European Software Institute, who are all the commercial partners on the project. And the project aims to do a number of things. The first is that in educational robotics, we see a lot of educational robotics projects, research being done, generally by people in computer science or engineering domains, but they don't have the pedagogic background that a number of us have. And so the focus of the project is to design and implement a framework of best practice, looking at what's already being done, but also what's being done by our partners. This comprises of creating an educational robotics activity template, so something that's a bit broader than a simple lesson plan, but not so vague as something like a scheme of work that might last maybe over a month or 2 months. And really thinking about what are the components of educational robotics that are different to a normal lesson. We're creating a repository of resources for teachers, and we're running workshops with just over 4,000 students across Europe. And this comes under an imperative from the European Commission that we need to increase students with 21st century skills, increased engagement in STEM subjects, so science, technology, engineering, and mathematics. And we want to get more women in STEM. And these are imperatives both in education, and I'm talking right the way through from primary all the way to the end of secondary or K to 12 education, and also getting more women in STEM careers. So this is kind of the frame, the background for the project. But robotics in education really isn't that new. It's been going since, kind of the 70s, really, with the work of people like Seymour Papert, built very early robots, which were programmed by students. So we already know quite a lot of stuff. And we actually already know that educational robotics activities are likely to increase STEM knowledge, interest, attitude, and motivation across both genders, but actually particularly for girls, which is really interesting. And there's a number of possible reasons why, but generally speaking, the research doesn't go into it very much. So that's one of the things that we're looking at with the evaluation that I'm running. And what we see is that robotics, educational robotics activities are a great way to develop 21st century skills. Again, not really revolutionary knowledge this. I think some of this is possibly quite obvious. But with this project, what we're trying to do is actually unpick what's going on during these robotics activities, where you have single gender groups, so all boys or all girls, mixed gender groups, so we've got some boys and some girls. And what's quite interesting, what we're seeing so far, I've got lots and lots of video data from all around Europe that I'm going through at the moment. And what we see is when we've got, say, for example, 2 boys and 2 girls, we tend to get fairly good collaboration and teamwork going on. Where there's a gender imbalance, so there's only 1 girl in the group or only 1 boy in the group, those children tend to stay quite quiet. They follow along with what everybody else does. And maybe that's actually quite good collaboration, but it's interesting that that happens. Going back to our equal gender groups, what we also see is that our groups tend to pair off. So we've got 2 boys, the boys work together, 2 girls, the girls work together. And actually we tend to get cooperation between those 2 groups rather than collaboration. And communication tends to break down. Again, this is really interesting. If we're going to get more and more young people into STEM subjects, things like collaboration, teamwork, communication are really, really important. So how can we ensure that these young people are developing these skills in a useful way that they can apply to with people of different genders? So we're looking at, like I say, collaboration, teamwork, communication, critical thinking, and along with that, reflection as well, reflection on learning, computational thinking, and of course, more broadly, problem solving, and of course, creativity, leading to innovation and entrepreneurship. So we're looking at a lot in this project, basically. But specifically thinking about the virtual world element, everybody else on this project, all the other partners, are all running robotics workshops in their countries. And they're all with physical robots. And because of some of my past research, I was really interested in actually what would be the difference if we used virtual robots in a virtual world. Would we be able to use them to support similar outcomes? Would there be new opportunities? And what would be the limitations? And in this, I'm thinking about both the pedagogical, so the teaching and the learning, the technical, and the outcomes for the learners, not just in terms of what they learn, but also in terms of their experience, because we need them to enjoy this stuff and want to participate. So why would anybody be interested in doing virtual educational robots? Well, there's a number of reasons. First of all, the cost. Things like Lego Mindstorms or even Raspberry Pi kits do cost quite a bit of money just to purchase, particularly a class set if you've got 30 children and you want to have one between 2. You've got to buy 15 of them. And all of these kits need to be maintained. Also, parts go missing, bits go missing. And this becomes less of an issue, potentially, in the virtual world. They can collaborate at distance, so we can get children in different schools to collaborate on a project together. They can develop digital literacy and competency. Of course, we can have multiple users, and it supports in situ engagement. Now, this is not the first time that I've done this. I've had a little bit of a proof of concept activity back in Second Life. And there's a little picture of the Slurtles when they were first created. And the first project was actually looking at constructionism as a pedagogy in the virtual world. Constructionism, for those who aren't familiar with this, is the idea that by exploring, testing, and extending our understanding through the construction of shareable, personally meaningful artifacts, we can really develop and enhance our learning. And this was implemented with adults with very little experience of programming in Second Life and using Slurtles, Scratch for Second Life. But for this particular project, the one I'm working on now, I wanted to move into OpenSim. Why? Because it's a project with 7 to 18-year-olds. The schools want control in terms of privacy and protection. They need reliability. They need a reliable system. OpenSim's been it's really come on leaps and bounds since the stuff that I first did in Second Life. It's low cost. We can also have a focus on the task, on the robotics tasks we're asking learners to engage in, rather than them having to go off and find resources, for example. And it's a very flexible environment in terms of the design. So at this point, I'd like to pass over to Pathfinder.
Cool. Thanks a lot, Carina. I'm going to go through these slides really quick and just give you my perspective as the consultant and the contractor or developer on creating, setting up these spaces for Carina in OpenSim. And the 3 questions I want to go through is really, talk about why OpenSim was a great technology match for the project. How did the age-appropriate design influence the content and configuration of the grid? And in particular, how did the hypergrid-enabled content enrich the build? So the first question, why was OpenSim a great match for the technology? And there's really nothing else out there in terms of an in situ and atomistic content creation platform. By in situ, I mean people creating at the same time, in real time, in an environment that's live. And atomistic, meaning the tools are there to build things from very, very small components. You're not just given like, here's a chair. It's like, well, you have to build a chair out of prims. Multi-user interactions, full control over the grid. The privacy and content backup was a real big issue. And also, we have the option now, obviously, for running a local grid off a USB drive with OpenSim, in particular with Ferd Frederick's Dreamworld software that allows you to set up your own grid locally, so that the project could be instantiated in schools that maybe don't have access to to servers on the internet. And in particular, in terms of content creation, OpenSim has come leaps and bounds in terms of the availability for content. In addition to a professional community. The way the grid was set up is that no one else can teleport into the grid from other grids, but administrators who have logged into the grid can leave. So they're able to free range, the administrator are able to free range, like Carina and myself and any additional teachers in the future can explore the rest of the grid. So that opens up a great big potential for growing the community, which is critical because in academia, it's all about colleagues. It's all about getting connections to other people. Oops. How did the age-appropriate design influence both the content and the configuration of the Slurtle grid? I just wanted to back up here because I love this image here. That's the space where the students collect a lot of their resources. Some of them including avatars, right? So we had to create age-appropriate avatars, both human and non-human, and allow local accounts that are locked onto the grid. We created the usual socializing spaces and spaces for play, and also creating an environment where there's a lot of reward for exploration, which is always critical, and the sort of classic orientation pathways and sandboxes. So all of the things that most people here know intuitively is important in building community. Those are the types of environments that that we set up in this space. But really, this thing I really wanted to stress is the hypergrid enabled content enriching the build. There's an incredible amount of quality content that's needed to build out any environment like this. And my focus is really on level design and user experience, and maybe tweaking some highly customized content. But there's a huge need for things like quality models of buildings and trees and avatars and furniture and so forth. So I spent a lot of time looking across the hypergrid and both free content and content for sale in places like Kitely Marketplace. And by the end of it, I had a list of over 60 people because I wanted to keep track of who were all the content creators who were providing content that could be used in this project. So moving forward, I'm going to make sure that all of those folks are always recognized in any presentations or anything like this. And here's a list of all of them here. And if you go to that link, there's actually a backup copy that I have running on an Outworld's Dreamworld build running on my desktop if you want to poke around and see what it looks like. And lastly, I wanted to mention that we'll put the slides up after the presentation is over, and there's the URL for it. And that's it. I wanted to hand it back to you, Carina, so you can talk more about the cool details.
Great, thanks, John. That was actually quite a nice little chance for me to have a go at trying to tweet the conference presentation whilst presenting, which is an interesting experience. Hopefully some of you will see that soon. So just to give you a little background to the Slurtles, which you'll see a couple of them just floating to my right by the Avacon presenter podium. Slurtles are designed to be what we'd call low floor, so they're very easy to use, wide wall, so that we can create a really wide range of things with them, and also so they've got a high ceiling, so we can make something very simple, so we can engage with them very easily and quickly, but they also allow us to create quite complex things and engage in conceptually complex ideas. And really what I've done is I've stolen some existing and wonderful ideas, things like Lego bricks, the idea that you can just take these very simple little bricks, click them together, and we can make something really quite complicated with them, really just limited by imagination. We've got turtle graphics, which some of you will be familiar with, a little line drawing program whereby you program the turtle and it draws a line as it moves. We've got Lego Mindstorms just below that then, which is a robot in the physical world. And then on the right-hand side, we've got Scratch, which some of you will be familiar with, which is a graphical programming environment. And basically, I'm taking all these ideas together and putting them into Slurtles. So I'm going to ask my glamorous assistant, John, to kindly give us a quick demonstration of the Slurtles in action.
All right, here we go, operating live without a net here. Let's see here. So if you look at the turtle, the Slurtle that's sitting on the ground near the podium, let me turn his scripts on here. And let's see here. Oh, come on. Oh, here we go. Okay. If you click on him, you'll see he goes, "Woo! I'm drawing a rainbow." There you go. And that's just a basic, series of commands you can issue. But one of the cool things is, and if anybody clicks on it, yes, it'll just obey your command. So it's going to now just keep drawing a rainbow into the sky forever. That's awesome. And then the other one here that's floating above the, let's see here, turn the scripts to running. Okay, the one that's above the ground here, when I click on him, he draws a star. See, and it's really interesting, kids look at a star, it's like, how do I draw a star? And they realize, okay, there are angles, and one is 108 degrees, and one is 36 degrees, and how can I, from the turtle's perspective, draw that? And so it's a very fun, very tangible way to visualize mathematics and to visualize the concept of, if this, then that, which is how you program robots.
Great, thanks, John. And off the turtle goes again. And the way it's programmed is just using, well, I've got a picture of Scratch for Second Life, but we've got a Scratch for OpenSim as well. And we just click and drag our blocks from the left-hand side and build up our script on the right-hand side. So John's using a when I am touched. So every time you touch it, the turtle goes around again. And you just press the copy Linden script button, and that gives us our text style language just to be able to put in our turtle. And the turtle's just, every time it moves, it draws a line by using the pen down command. So really very nice and simple for the learners to use. They can engage in 3D graphics or thinking about 3D mathematical concepts, which is fantastic. I'm being told to wrap up, so I'm going to just steal 1 extra minute from question time. Just to show you just a picture of the stairs there. and an example script. So you can see that's quite simple, but if we had to write that in a text-based language right from the very beginning when we haven't done any programming before, it's going to be quite complicated. And these are some of the things that our learners have created using Slurtles. So we've got an interactive piano. One group decided to make an obstacle course. Another group made an enchanted forest, which was all kind of cool. And just to finish up, I just wanted to mention to you a couple of next steps. So I'm piloting this with a couple of schools, one in the UK and one in Ireland. And I'm co-creating lessons with the teachers to introduce students to computer programming, 11 to 12-year-olds, and to actually, they will be using programming, of course, but actually to learn different mathematical concepts. So instead of about learning maths, the students use the turtles to become mathematicians. So they explore and work out the mathematical concepts themselves. And that's with 12 to 13-year-olds in Ireland. And from that, so we're going to get feedback from the students and the teachers, refine the island design a little bit, and be looking to recruit new schools. And I've actually already got one in Greece that's really keen to get involved. And obviously we're talking about primary, yes, middle school and secondary school. So if anybody would like more information, I do have a journal article, which I think John's put up for me in the Expo Centre. And otherwise, feel free to drop me a line. So thank you very much, everyone.
All right, Carina and John, thank you very much. These turtles are so much fun. And Carina, I think the programming that you've come up with for these kids is gonna be wonderful for all of them. I want to remind the audience that you can see what's coming up on the conference schedule at conference.opensimulator.org. Coming up in a little bit here at 7:30 a.m. PST, our session entitled Remote Controlling Open Simulator. So we will see you all in a little bit here as we change our speakers out. And if you have a little bit of time, you can go over to OSCC16 Expo 3 region or Expo 2 region and check out all of our booths there. Thank you.